Hello, everyone. It's really great to be here. It's really a great honor to be invited to speak here today and to see so many old friends. It's really exciting for me because I have not been to CVPR for a while, and I have not been very active in doing vision research for the last 10 years. Even so, I still talk to my colleagues and my students and occasionally challenging them. So today I actually will talk about, just share some experience with you, what we have been doing in Microsoft in moving from research to product to commercialize computer vision. So after I was invited, so I thought I should just at least take a look at the website, what's going on, what's happening in CVPR nowadays. As I said that the last time I attended was 2007. The first time I attended was actually 92. I believe it's in Urbana, Champaign. I think we had like 200, 300 people there at the most. Now this year, if you look at this long list here of corporate sponsors, so we probably have roughly about 130 corporate sponsors. It must be a great field to get in nowadays. Even parties probably now are so much better than in Urbana. So it's really amazing. So I just feel compelled to look back, 10 years ago. It was 2007, and when I last attended CVPR, we had only 9 corporate sponsors. Only 9 of them. Yeah, some of the names I don't even remember. So if you look through so many years, and I really need to I talked to Anthony at the lunch today, but I really need to verify with Terry Bode, since Terry knows everything about the money. So whether that's true or not, in the last 25 years, Microsoft Research has been the only one that actually sponsored every single CVPR. So at Microsoft, when we say we are very committed, to long-term research in computer vision, we really mean it. So I'm very happy to tell you that Microsoft just became a diamond member of CVF, and the CVF Open Access Archive runs on Microsoft Azure Cloud. That really makes me very proud, and also makes me think back and way back, when we actually started Microsoft Research. So lately, everyone is talking about AI. Perhaps everyone is afraid of not talking about AI, because the opposite of artificial intelligence is natural stupidity. So that's why people just talk about AI. Every CEO is talking about AI. But 26 years ago, in 1991, Bill Gates created Microsoft Research and asked us a general AI question. So he said, what if we could build computers that one day could see, hear, talk, and understand human beings? So to me, it's really about the general AI, what we can really do. That's exactly actually what happened in MSR, since 1991. Natural language group, speech group, and the computer vision group was those 3 groups were among the first groups we ever really created. So over the years at MSR, we're committed to doing research and to leverage our research to build great products to benefit our customers. To commercialize computer vision research, we think about a cycle. That's from research to product to business. It's really a flywheel, and the more it turns, the more we learn, and the better we get. Different companies definitely take different approaches and different strategies to speed up that cycle. At Microsoft, we believe that the key is research. So then the question is really that, how do we organize research? I feel that we actually have a pretty good track record over the last 25 years, 26 years. Honestly, the #1 priority is to create the best environment for our researchers to conduct the research and have impact. So what does this really mean? Well, we keep our researchers happy by giving them freedom to choose what they work on, the problems they like to work, and the areas that they would like to pursue. And perhaps more interestingly, the style of research they choose, whether this is curiosity-driven or deployment-driven. So in the end, it's really up to the researchers what kind of impact they would like to have in their lives. It's academic, engineering, product, or business, or something else. So let me start with curiosity-driven research. It's really our path to secure technologies for the future. So I'm going to share a couple of examples of curiosity-driven computer vision research projects I am familiar with. So the first project I will share is surprisingly, not surprisingly, panoramas. So that's about 300 degrees images in the videos that I actually had a chance to work with Rick Zalitsky, Sim-Min Kang, and many other people in MSR. We just loved the panoramas. It didn't really matter. We loved the panoramas. Rick loved the panoramas. I loved the concentric mosaics. Sim-Min liked the panoramic videos. And so that's what we did. I'll show you a very short video, brings back the fond memories. Can we just bring up the video?
Users navigate from room to room using a simple game controller interface, allowing them to move forward and backward, look around, and zoom in and out on areas of interest.
So it's a very short video, and nowadays, of course, panoramas everywhere. But when we actually created that, it was very early on. Microsoft was among one of the first to really propose those good ideas, how we construct the panoramas, how we build those capturing systems. Even though initially we had no plan, what kind of products we eventually will ship. By the way, in case you missed it, I want you to take a look at that. Our beloved Dr. Sim-Min Kang, have his 360 video camera here on top of his head, walking around the garden, actually creating a lot of interesting panoramic images there. And I want to remind everyone that before self-driving cars, there was self-driving human. And that really shows the dedication of researchers. And the reason we do research is we actually feel very passionate about it. We really do everything to do great research. I think this is just a great example. Second example I'm going to show you is really in image understanding, and which has become a more focused area in computer vision. And the reason the success has largely been driven by deep neural nets. I'm sure more than half of people in the room today probably work on deep neural nets. In 2015, our researchers proposed 152 layers of DNN called ResNet. So I'm going to show you an animation here. And if you can really count that, it's 152. And those researchers, some of them have left, can never answer my question that why 152. You guys have to continue work harder and really get to those fundamentals here. So it's really fun. So you're probably already using that. One of those the ResNet really popular out there. I think one of them is actually ResNet 50. And with the ImageNet classification challenge, it was actually pretty clear that the deeper neural nets you get, the more accurate you get. So at that time, this 152-layer ResNet won the challenge. We actually won the first place in all those 5 major categories in 2015, but we didn't really stop there. So we continued to work on this problem, and in 2015, we won those things, but in 2016, we actually continued to work on this, what we call the region-based, fully convolutional framework for instant recognition and segmentation. And we won first place in 2016 COCO Challenge in segmentation track, leading the rest of the field by a fairly significant margin. So let me show you some short video here and see some of those algorithms in action. So those are some fairly standard benchmarks. It's really amazing to see this kind of results. I think just a few years ago, it's definitely you didn't think it was even possible. So those are a couple of examples we say, well, researchers really like what they really want to work on this kind of problem. So they just worked on this kind of problems. We don't really worry about whether we work on these things, we actually can really build a product. So this is one kind of style of research that we call the curiosity-driven. So let me switch gear and talk about the deployment-driven research. And I'm going to use 3 examples. When I say commercialize computer vision, I really meant more about doing deployment-driven research here. Remember, product and the research really reinforce each other. They are not really completely separate. When we talk about commercialization, the first thing you got to realize is that you should step back and think about, what are your customers? What customer segments you really care about? Then you actually work backwards to think about what kind of needs, what kind of pain points they really have. Then you design those systems and the products to cater for that. So I'm going to walk you through some of those customer segments that we think about at Microsoft and the kind of offerings that we have been developing for our customers through our research. So I'm going to start with the first, perhaps the biggest category is called consumers. Certainly, image search and video search with Bing would be one of those examples. But instead of that, I'm going to show you a simple example called the Microsoft Pix. This is actually the AI camera, the intelligent camera app on iOS. And our users love it. We actually rolled out not too long ago, and hopefully some of you in the audience are already using that. And with deployment-driven research, it's really our path to have immediate and tangible impact very quickly to the products and to the business because customers can really enjoy it. So this is an app, last year was rated as one of the top 10 apps by the New York Times. So give it a try on iOS and let me know. The reason I like this is because now I have a chance to brag about the amount of incredible research work over so many years at MSR. Now we actually have a chance to put them into a product. And I just illustrated about the 20 papers here. I will animate the next couple of pages. You can see that. I look at those great names here like Zelinsky, Salison, Cohen, and all those great people that. And now we actually put their technology into one product, and we can ship it. So as I said that, we probably have 20 ECCV, ICCV, CVPR, SIGGRAPH papers in that little app. So we have more papers here and more papers here. We started to think about building an app like this probably early January, and we pushed for it, and we pushed for it. Now we actually have a fairly sophisticated product with a lot of features like this. This is actually the latest build with many of those features coming from those 20-some papers I mentioned about. So I'm going to share with you very quickly 3 interesting features, and you may or may not know. The first one is actually what we call the best of burst. When you take a photo, very often when you go back and you look through so many photos you took, you say, this one looks really good. You say, I really regret that. I should have taken the photo slightly differently. One of the biggest regrets people have is at a very important moment, your eyes are closed. So this is something that we think we can fix. So that's exactly what we actually did. So we actually take 10 pictures instead of 1 anytime you tap. It's actually before and after you tapping it. Then we actually keep the best photo by going through the low-level and high-level features, including something detecting whether if a subject in the photo actually closed the eye. Then for those best photos we keep, and we defer the processing. For the rest, we just delete that. So that is actually the first feature. So whenever I try to tell people you should use Microsoft Pix, I always say, if you don't want your eyes closed when you take your picture, and use Pix. The second one is actually live picture, a live image. So live image is really, you go through the burst of images, and you figure out that if you actually have interesting enough motion there, if you do, you try to loop them together, and this is what we do. And it smartly detects the motion so that you don't need to even take a lot of pictures there if you just look at a whiteboard or parking spots or receipts. So that's the second feature I thought you might be interested. The third one I feel very proud is that how quickly we actually rolled it out. This is actually artistic style transfer and the fast painting, which we just released into the app about a month ago. In fact, the technology behind that was presented this morning at the poster by our researchers at the CVPR here. And you can see at the bottom, each original image at the left can apply different styles. And that's what we can do. I explained a little bit here what's really happening here. And you can see the paper from CVPR here. So the idea we have is actually called the style bank. We found that a visual style can be explicitly represented as a set of convolution filters in a nonlinearly decomposed image space. Think about the image autoencoder. So once we learn end-to-end, the style transfer is cast as the convolution filtering process in that embedding space of the autoencoder. And each style is explicitly represented as a set of convolution filters in that space. Then it's going to be easy. The set of all styles, each represented by a convolution filters bank, is called style bank. So you can really apply, depending on what kind of image is coming in. And it does have some distinctive features. So this explicit representation targets separating the image style from image content. And it enables fast incremental training and other advantages like a region-specific style fusion. So it's already in the app. You should give it a try. What I really want to point out using this example is this process of push and pull. When you do this kind of deployment-driven research together with the product side. It didn't take us too many months to really ship it. However, during that process, the research team and the product team had many iterations to get to the best possible technical outcome. So this is just one very important characteristic of deployment-driven research. You just need to be willing to spend a lot of time to think about why you do this particular research and what is the additional things that you really need to do. Let me move to some other examples of the customer segments that we really care about when we talk about commercializing computer vision. So we care about not only consumers, we care about the developers, we care about the information workers, we even care about the business developers, those people in those functional teams in corporations. So Microsoft's mission is to empower everyone and every organization on the planet to achieve more. And we really mean that. The next example I'm going to show you is called Cognitive Services. Really delivers on our mission, addressing the needs for all those customers, even if they are not really that technical. Let me tell you a little bit about Microsoft Cognitive Services. It's really a set of APIs powered by Microsoft Azure Cloud and the other state-of-art AI algorithms, much of that coming from MSR. It's not only just computer vision, it also has speech and other things as well, so that developers and the business can use this suite of services and the tools to really, and coupled with their own data and the application scenario, can build their own intelligent apps, which are likely personalized and intelligent. These easy-to-use REST APIs help make every developer an AI developer. And 2 years ago, we actually started out Cognitive Services with only 4 APIs coming from MSR. Today, we have 30 AI API services in vision, speech, language, knowledge, and search. Plus, recently, we introduced these labs, so we can really throw out some things that we don't think they are really ready, but we actually would like the users to try and give us feedback. And those APIs are already powering many products across Microsoft. And the Microsoft products are already using some of those APIs. And the vision alone, if you look at what we're offering out of those 30 APIs, we actually already have 7 computer vision related APIs and services. I'm going to use an example of image captioning to talk to you about how we have been successfully applying those vision APIs and how we actually do that, how we go from research to product to commercialize. Our image captioning API really started with our award-winning algorithm in 2015 COCO captioning challenge. Our system actually won the first place, but only passed Turing test 32% of the time. In contrast, if you take a look at it, humans actually can do much better, with 67% of the time. But that's encouraging. But that's good enough that we can actually build a service, then deploy it, and collect the data and think about what we can really do. So we rolled out with a website called www.captionbot.ai. And the people can just submit their own pictures and decide whether they like it. We tried many of those examples. This is one of those fun pictures that some reporter tried himself. So this picture reads like, I think it's Satya Nadella standing in front of a flat screen TV and he seems happy. It's always good that if your CEO is happy. And we have more examples. And you can, of course, try yourself. Some of those pictures are relatively easy, and some actually pretty fun. And you can really try that and compare with similar services out there, I think, on the market, so that you can compare. What's really exciting to me is that through this deployment, that we actually have learned a lot. So far, captionbot.ai has already served more than 10 million requests. That we have collected a lot of the user feedback. More than 60% of the user feedback give us 3-star, 4-star, or 5-star. That's very, very encouraging. Remember earlier I told you that we could only pass Turing test for 32% of the time. And we're actually improving, but at that time we could only pass 32%. Now, once we collect a lot of data, we can dive in to really understand what's really happening with our system. Let me share with you some very interesting observations here. So I have a data plot here. On the horizontal axis here is actually user rating, 1, 2, 3, 4, 5. No, you're going to the right is actually better. The vertical axis here is the model confidence score coming out of our system. So the higher the better, from 0 to 1. So this is actually what we have plotted. So then we take a look at which ones actually people like, and we actually also feel very, very confident. It turns out that we actually have a lot of images that will get very nice captions. Those are actually pictures with natural scenery and the common objects that we already do very well. So that's not surprising. What's more interesting is actually we take a look at the discrepancy between the model and the human reading. For example, that the user's actually pretty happy with the results, but we actually don't have a system with that level of confidence. So that's very interesting. So what's happening there? Then on the other hand, sometimes the model actually feels reasonably confident, but the users think it's terrible. It's completely missed it. How could you even miss this thing? And so it's probably likely that we have some features there. The model can pick it up feeling reasonably confident, but those objects are just not really recognizable for us to really have a good caption. To me, probably most interesting thing, the most low-hanging, if you go through the data, then you will realize that there are a bunch of images we just never really paid attention. Images like cartoons and the drawings. If we care about Homer Simpson, then we probably should work on this kind of pictures. And through these fast iterations with deployment-driven research, we significantly improved the quality of our algorithms, which in turn allowed us to provide much better services to our customers. You can see over time how we continue to improve the quality there. So with Caption Bot, so now we have this opportunity to really go very aggressively to apply this kind of technologies into Microsoft products. That's exactly what we did. You may not know that. Now, with Microsoft Word and the Microsoft PowerPoint, you can actually upload a picture there, and we will automatically write photo descriptions for you. So if you use Office 365, you can open your PowerPoint, and you turn on intelligent services in the setting, and when you load an image, we can serve you an image caption. When we are confident, we give you the whole sentence. When we are not confident, but reasonably confident about some entity recognition, we can still offer those entities to you, so you can give it a try today after you go back to your hotel room, and if you have Office 365. So we have really learned a lot through the last 2.5 years of shipping cognitive services. One thing we hear loud and clear is that many, many more people want to use this kind of cognitive services, and yet many of them are not really computer vision or deep learning experts. So people really want easy-to-use tool for prototyping, improving, and deploying a custom image classifier, ideally to a cloud service, even if they don't have a lot of computer vision and the deep learning background. So that's why we actually designed a system called a custom vision service. So I'm going to invite my colleague, Anna Ross, to do a demo for you and to show you how easy it is to build this kind of services. Anna. Thank you, Anna.
Hi. So our team is primarily focused on the cognitive services team on how do you empower people who aren't experts in computer vision to be able to plug in here. To be able to use things like computer vision. So for a long time, we've had this computer vision service where you give it a picture, returns back 1 of 2,000 tags, which is like a pretty reasonable thing to do. But the most common request that we got is customers said, well, this is great, but I want to be able to recognize my own product, my own widget, my own, the animal that I care about. That unfortunately does not scale. So we kind of became interested in the question of, can you enable somebody who has no, yeah, there we go. That's a good call. Can you enable somebody that has no background in computer vision to build a reasonably robust classifier? And so we built this tool, the Custom Vision Service, to sort of answer that question and to work on it. You guys, Can you get me the Wi-Fi thing? So we kind of assume that it's reasonable to say that there's a class of problems where this is true, and definitely we think that there's a set of image classification problems where somebody that is a non-expert can build a reasonably robust classifier, even without any, thank you, sorry. So it seems to be relatively true for image classification. So this is a tool that lets you upload a handful of images, say 30 to 50 to 100 images per class, hit train, and then have your classifier deployed to an API endpoint so that you can start prototyping. The idea here is you ought to be able to build your classifier iteratively. So the customers who are using this service, that's not the right demo. That's what happens when you. So the customers who are using this service don't have a very good understanding of, say, what is a diverse training set. So often people will actually start off doing things like uploading lots and lots of images on a white background and then trying to use their classifier in the real world. Or they'll come up with these sort of complicated voodoo explanations of why things aren't working. So for example, we used to have a data augmentation step that did a flip. And customers would come up, and we had a customer that was trying to recognize left-handed and right-handed baseball players. And they came to us, they set up a call, and they had this very long, complicated justification of why the classifier wasn't working, when in fact it was something that we were kind of doing on the back end. And for us, it became obvious very, very quickly that there's a lot of stuff that we'll have to do to sort of guide users to actually build a classifier, but also that there is a set of kind of real business problems where a good enough classifier can bring a lot of value to a customer, and they just don't have that background or that expertise. And so here I have a demo classifier I quickly put together, just recognizing a couple of fruits. Some of these are Hawaiian. Trained it, give the customer kind of some high-level performance metrics. And then the really clutch thing for us was being able to actually show them what are the images that they're submitting to their classifier, and then we rank them, in this case, using kind of entropy by a predicted class, a couple of recency signals, and a handful of other signals to give them an idea of which images they have to kind of go and label. Because in most cases, customers start off with one set of images that are highly dissimilar from the actual images that they're encountering in the real world. So here, these are some images I submitted to my classifier recently. Thinks this is a passion fruit. No, it's not so good. Apple, this is better. No, this is like banana. Okay, that's not where we want to be at start point. But all I have to do here is I'll take a couple of these images, and I can tag them as apples. Run. And those have gone away. They've been added to my training data set. I hit train again. And then within a minute or so, I'll actually have an updated classifier here that I can go try again, until I have something that works. And so for us, it was kind of an open question when we started this. Is this going to be something that real customers can use for business scenarios? And it has turned out to be the case that there are a number of problems where a sort of good enough classifier is sufficient. So we had customers that want to take user-generated content on their website and just sort it according to some set of filters that they have. Or customers that want to delineate between which of their widgets, which of their products someone is submitting in a support ticket, where it doesn't have to drive itself and it's not curing cancer. You just need something that is good enough to be able to make some business process more efficient. And so for us, it's been kind of an interesting experiment, but it's also very clear that sort of across the field, there's a lot of space for improvement, for an enhancement of the kinds of scenarios where you can kind of let somebody with that expertise DIY. Today we're doing classification. It's kind of obvious that object detection would be kind of a relatively straightforward addition, but there's all kinds of things where it's not very clear that you can do something like this today. And so we're highly interested in this set of problems. Finally, when you have something that you're building for developers, it needs to be relatively extensible. So for this website, every API that powers kind of the website that you see here, we've actually published the APIs for this, so there's no kind of private APIs, with the intention that you actually, if you don't ever want to touch the UI, you don't have to do so. And so that lets you do some neat things. So for example, one thing that I've actually done here is that I have a little script which lets me take this project and send it to a training data as a service company, Mighty AI. I'm sure they're outside, and I'm sure they're happy to talk to you if you have questions. So I actually can send my images kind of in my predictions tab that I wasn't particularly confident about to a data labeling service and actually build a pipeline for kind of automatically improving my classifier over time. So kind of these extensibility tools let developers actually kind of build a whole process with their classifier and really use it for kind of a real business purpose. Finally, we have kind of a long-term vision for this application, which is that obviously it's nice to have a cloud service and get kind of a lot of leverage from having a managed service like this. But it's not the only place where you might want to actually run your classifier. And so one thing that we're sort of working on now is how you let people export their classifiers to kind of run them wherever they want. And so, for example, here on my phone, it's a little bit of a preview what you'll see soon. I've exported the classifier that I built earlier. And so I've exported actually to Apple's newest runtime. So you can see here, demo God's willing. I'm actually able to see that I have an apple here that I'm holding up. And so we kind of really believe that customers ought to be able to, within, 5-10 minutes, build a classifier, take it wherever they want, and start using it for their business. Thanks.
Thank you very much, Anna. I thought, especially for this audience, I thought it's very important to realize that not only we do deep research, we really want to make sure that those technologies, those tools are available for many, many more developers. And there are millions of developers out there. We want them to become more capable doing computer vision and AI. I'm going to bring my slides up here. So this is really the second example of deployment-driven research I wanted to talk about, about cognitive services, where we move a lot of research technology, algorithms, systems into the products. Now let's move to my third example. Now let me move to my third example and our last customer segment. We call the first line or front line workers. And there's exciting stuff happening with HoloLens. I'm sure by now you have heard about the Microsoft HoloLens. Hopefully some of you have already tried it. I'm going to give you a quick tour of HoloLens in case you haven't really used it. So as you can see from this picture here, from the front, you can see the outline of our holographic display and some of those cameras actually visible from the front through the visor, which is really there for protection. So the red extrusions are the speakers you can see there. The first piece we will focus on is the HoloLens sensor bar. It's actually HoloLens sensor bar. Let me break down for you. So you will notice that the number of components is so many of them that we build into the fit system. Because we have to adjust for different head shapes and sizes, as well as allowing users to wear glasses before they put the HoloLens on. So the whole front end of HoloLens can slide backwards and forwards. It's very important for me to point out that so you don't see fans or heat sinks. We really want the system to be robust, reliable, and comfortable. We are actually space flight certified. So HoloLens have been to the space station. So it's really, really amazing. So it's really hard to build this because of all the challenges there, not only software, hardware, but also optics. So let me show you a real-world application that is actually by a Japanese construction company.
小柳建設は創業以来事業を通じて地域社会の成長発展に貢献することを第一に考えてまいりました。先端技術への取り組みを通じて時代を引っ張る存在となり、先端技術を地域の皆様に提供する使命があると私は考えています。
HoloLensを使って建設業界にイノベーションを起こし、全く新しい世界を作り出していけると確信しております。建造物のホログラムを使って計画から引き渡し以降のメンテナンスに至る全ての状況を追跡できます。計画と実績の施工精度を比較するだけでなく、予測モデリングを行い、将来必要な補修作業をタイムラインに追加することもできます。また、お客様との最終点検に同行できないスタッフも遠隔地から作業に参加することも可能です。
壁の中にあるものも透視図としてお客様にご覧いただくこともできるようになります。例えばお客様からの要望で変更が生じた場合、その対応策や予算調整を速やかに行うことができるため、こうした仕組みがお客様の満足につながると考えています。引き渡しの際にはプロジェクトのホログラムを含むすべてのデータをホロレンズに入れてお渡しできます。
I really like this HoloLens project and the product, and it's a great example of how our long-term research has inspired a great product, and on the other hand, our products have inspired great research. So let me take you through a number of projects along the way over many, many years in Microsoft from research to product. As you know, we have been doing computer vision research, especially 3D vision, for many, many years among many of our researchers across all our labs. So together with the Connect team, in 2010, we actually shipped Microsoft Connect with Xbox. So that actually gives us the capability of doing 3D reconstruction very conveniently. So as soon as we actually had this product called the Connect, our Cambridge Research Lab researchers did a very interesting project called the Connect Fusion. By putting together multiple Connect sensors and reconstruct a room-like environment. So that's 2011. So in 2012, another group of researchers also in Cambridge Lab did another project called the HoloDesk. So this is where they realized that if you have a 3D, reconstructed 3D environment, now if you actually put a virtual object there, let's say this is a kind of desk environment, you put in a virtual object there, now you can really manipulate this kind of virtual object in a real environment that you just reconstructed. That eventually led to the birth of HoloLens by some brilliant engineers and designers in Microsoft that we actually finally shipped in 2015. As you know, it's very difficult to do this kind of products. There are very few, if any, other products out there in the market today for this kind of AR, MR goggles. But we didn't stop there. After we shipped the HoloLens in 2015, last year we actually did a project called the Holoportation. So that is actually teleport with HoloLens, teleportation with HoloLens. You can find more details by look at on the video actually on YouTube. But let me actually come back to HoloLens. So HoloLens leverages a lot of computer vision technologies. We need to know the environment such that we know where you are and we know what's around you. So that's actually important. And we also need to understand what you really want to do and where look at, what kind of gestures you actually have. Let me show you a couple of videos here. The first video I'm showing you here is really tracking. So show how robustly we track the head motion through the camera and also onboard IMU sensors. So that's what we actually do. Second video I show you is that once we have this kind of robust tracking, we can actually build a 3D map of the environment around you. That's also very important. Now you can actually move around in the environment. The last one is actually now we can actually do some gestures so that we know what you really want to do. That's actually in combination of other sensing modalities such as speech. So clearly there are so many those things is already working, but it needs a lot of improvement. For example, tracking really needs a lot of improvement. And the good news for us is that the latest developments in DNN are really helpful. But we need to run those things locally because of the latency. So that's exactly what we did. So we worked on some of those state-of-art DNNs for recognition, and with the help of Microsoft CNTK, the deep learning toolkit. So we run them locally and on this battery-powered device. So that's actually that's what we did. And we need to do that. We need to really do that for this kind of device, because this HoloLens device is really untethered. So towards this, so we are really doing this whole thing for tracking and for this kind of gestures. So when you need to do that, so what is the solution? This is a lot of computation. So everyone nowadays is concerned about, after you train a very powerful DNN, can you really run those models locally? That's exactly what we do in Microsoft. So we decided that we should create custom silicon to do DNN for this kind of tasks, including hand tracking. I want to give you a little bit of background. So HoloLens actually contains already a chip called a holographic processing unit, or HPU. It's responsible for processing the information from all the onboard sensors. There are many of them, including head tracking camera, the IMU, the IR camera, and also time of flight depth sensor in real time and also in parallel. So today, I'm announcing that an upcoming version of HPU will incorporate an AI coprocessor to natively and flexibly implement DNNs. So HPU 2.0 supports a wide variety of layer types and other tunable parameters fully programmable by us. So I'm going to invite my colleague, Steve Anderson from the HoloLens team, to come on stage to show you a quick demo how we use this HPU 2.0 to do hand tracking. Steve.
Thanks, Harry.
Great.
Hi, I'm Steve. I'm happy to represent the HoloLens science team, many of whom you know, and many of whom are sitting right over there. Hey, Jamie. And I'm going to show you some of their work. I want you all to know that except for a few Microsoft employees who were sworn to secrecy when they started working on this, nobody, even people inside of Microsoft, has seen what I'm about to show you yet. So I'm pretty excited about that. We're going to show you a little bit about what's going on stage here to give you some context. If we switch to the video, I think, turn on the camera. What I have up here is a PC. It's got this sort of goofy looking board sticking out. That's a dev board. On that dev board, he's going to try and show it to you, is an early spin of the HPU 2.0. Here's another better sort of view of it. We have one stick, it's that one right there. Inside the HPU 2.0 is the AI coprocessor that Harry mentioned. And it's responsible for executing DNN inferences at high speed and at very low power, because remember, this thing has to run off a battery that sits on your head, and we want it to run for a long time. So connected to the PC via USB cable, I have a version 1 of HoloLens right here. We're taking depth images and IR and sending it to the PC and to the processor. I'm going to set this on and take off our high-tech cloaking device. I don't know if you can see over my shoulders. What we're showing is right now that what's on the screen is actually tracking what's going on with my hands. Now if we switch to the big screen, so you can see what's happening. There we go. So on the far left is the result from a ResNet 18 that's showing you hand segmentation right and left. And you can see it's doing that in real time. We're running that actually on our AI coprocessor. And then the middle one is showing hand part segmentation, 16 classes, again being done in real time, showing fingertips, palm, thumb, all that. And then on the right is our fully articulated hand tracking. That's going in real time as well. I don't blame you if you're skeptical, but I invite you to come by the booth, the Microsoft booth. We'll have the hand part segmentation and the hand segmentation demos running. You can try it out for yourself. You can take a look at the HPU 2.0 and talk to some of the people that actually coded this stuff, like I said, who are right over there. So that's it.
Thank you very much, Steve.
You bet.
Yeah. It's really amazing to see, how much we have progressed. I still remember, when I was a graduate student, and it's at that time with 2D images, videos, and the tracking hand motion is just so difficult. And now with this kind of powerful devices and the powerful algorithms, we make those things happen. So thanks, Steve, for this demo. So if you want to see this AI coprocessing in action and much more, you can actually stop by our booth in 136. And if you want to know even more details about HoloLens, you can go to Professor Mark Polife's tutorial on using HoloLens as a computer vision platform. And we have another tutorial for CNTK as well. As I think about all those opportunities we have to commercialize computer vision, I think about it really in two different buckets, and they are connected. Those things are intelligent cloud and the intelligent edge. So you already heard, saw it from Anna's demo earlier about the cognitive services. So we can package a lot of this kind of computer vision and AI algorithm in the cloud where we can really leverage a lot of those computing powers there. On the other hand, we have more and more those interesting computing devices from phones to PCs to HoloLens and to others. And with more and more computing power that we can embed into those devices, I see tremendous opportunity where we can really apply computer vision, whether it's algorithms or systems or services. So I'd love to show you more in the examples, but I only have that much time to show you a few today. But there's just so much more happening in our field right now. So I actually want to close where I actually began. So I hope some of the lessons that we have learned at Microsoft over 20-some years about accelerating this cycle from research to product to commercialize computer vision could be helpful to you. But if you want to do deployment-driven research and care about building products, remember, software engineering is first of all a social process. It's not really about who has the better design or who actually has an architecture is more provable. You need to really work with various teams, and you need to push and pull. You have to go through iterations, spin the flywheel from research to product many, many times. The magic is in the iteration. I know for this crowd, I don't need to overemphasize the importance of research. But as I see more and more companies recognizing the importance of computer vision, coming to CVPR and hoping to build great products with computer vision, I want to take advantage of this occasion to encourage you, all those from companies, to pay more attention, to invest more in computer vision research. In fact, I'm going to share you a story I learned not too long ago to finish my presentation. It's actually a great story from 1969 United States Senate hearing. So in 1969, the physicist Robert Wilson was questioned by a congressional committee about the funding for the accelerator at the Fermi National Lab in the United States. So he was asked by the senator, "Professor, will this accelerator contribute to the defense of the country?" So Professor Wilson replied, "I don't think so, but it will make the country more worth defending." So investment in research is an investment in the future. And the investment in research is an investment for a better world. I can honestly tell you that MSR has been an incredibly successful investment for Microsoft. I'm so proud of what MSR has done for computer vision community. And I'm so grateful that Professor Takeo Kanade and Professor Dana Bartlett created CVPR in 1983 so that we all enjoy having this opportunity to meet here in beautiful Hawaii. Thank you very much for having me.